All right, let's look at example 2. Example 2, similar problem here. It's saying factor m squared minus 121. So all we're going to do here is think about this problem and do the same process that we've done before. Okay, so the only thing that's different here is that there's no b value in this problem. So that's not a problem. We can think about this problem as m squared, and since there is no middle term, we could say plus 0m, because there's no middle term there, minus 121. If we wrote about it, or if we wrote it like this, or thought about it like this, then the problem would be pretty much the same thing that we did in the other problems, right? If I want to factor this, I'm going to get two parentheses, and I can go ahead and figure out what those are if I do the snowflake method. Again, if you have other methods that you've used in a different class, or if you just want to go ahead and do the traditional method, go ahead and do whichever method you like. But again, snowflake method, we're going to take the a value, the coefficient here, which again in 4.3, the a value is almost always 1, right? That's what makes these problems easier. So this is 1 and 1. A times c is negative 121, and now the b value here is 0. So now we're thinking about what multiplies up to negative 121, right? And there's only two things that do that, right? So that's going to be positive 11 and negative 11. So what multiplies up to negative 121, but also adds up to 0, right? It has to be 11 and negative 11, and that fits perfectly. Okay, those two things happen. So therefore, I can go ahead and circle these columns, and now I know what my factoring is. It's going to be 1, in this case, m plus 11, and 1m minus 11, and there's my factoring. Here's some practice problems. You can go ahead and pause this and give these a try to see if you get them right, or just follow along here. So practice problem, this letter C here, x squared minus 36. So same thing, this is almost identical to the first one, or the one above. You're going to think about this as x squared plus, there is no b value, so plus 0x minus 36, and so that's going to factor. We're gonna try to factor this into two parentheses, and we can figure out these factors by doing the snowflake method, or whichever method you choose. But my a value is 1 and 1. My a times c value is negative 36. And b value is 0 here, so I'm thinking about what multiplies up to negative 36, but adds up to 0. So the only thing that works there is going to be 6 and negative 6. So there's my answer, is going to be 1x plus 6 and 1x minus 6, or just x plus 6 and x minus 6. So there's my first answer. Part D is a little different. So whenever you factor problems, if there is, in all of these terms here, if there is a common factor that can be divided out, you always want to do that first. It's best practice. So you always want to think about that first whenever you factor anything in algebra. And that is, so this problem right here, if I look at the two terms that I have a 2x squared and a 32. Well, both of those can be divided by 2. I could basically divide each one of these by 2, and I could factor out a 2 before I even began this problem. So the way I would do that is if I divided 2x squared by 2, that would just give me an x squared, or a 1x squared. If I took 32 divided by 2, I would get a 16. So I'd have a minus 16 here. So the first thing that I do here is I take out this 2 that both of them have, and I put it out in front here. Now, this should make sense, and it should, if we multiplied this back in, right, it should be obvious that we would end up with 2x squared minus 32, just like we had when we began. Okay, so the first step, you always want to do this. If there's something to factor out, we're going to factor it out. Okay, you never want to miss that step. But now that we have this 2 out of the way, we're going to focus just on this x squared minus 16 and think about, can I factor that? Can I take x squared minus 16 and break that down? And so the answer is yes, we can. Can I do this right here? Okay. And so I'm not going to write out x squared plus 0x minus 16, but again, we have a polynomial here that does not have a b value, okay, just like the last two that we did. And so if we do that method here, we think about, I'm going to have a 1 and 1 here because I have a 1x squared, and a times c here is negative 16. And I think about the b value here, in this case is 0, and I'm thinking about what multiplies up to negative 16, but also adds to 0. And so this is going to be 4 and negative 4. 4 times negative 4 is negative 16, and 4 plus negative 4 is 0. So I have my factorings here, and that works. So I'm going to go ahead and put it above. So this right here breaks down to the 1x plus 4 and 1x minus 4. And there's my final answer. All right, so let's continue and try some more of these. D, we have x squared plus 9x plus 12. Okay, hopefully we're getting a little bit more confident and a little bit quicker at these, but I'm going to try to factor this. And again, just from that last one, you always want to get in the habit of asking yourself, is there something that I can factor out first here? Do all these three terms have something in common that I can pull out first? And the answer is no here, because besides 1, you can't divide anything out. So we're going to go ahead and try these 2 parentheses, and we're going to help get that by doing the snowflake method. So we're going to think about the a value is 1, we put right there. A times c is 12, and the b value is 9. So now we get into this question of what multiplies up to 12 that also adds up to 9, right? So we think about the combinations here. What multiplies up to 12? Let's see here. Well, 1 times 12, right? That adds up to 13. 4 times 3 multiplies to 12, but that adds to 7. 6 times 2 works, but that adds up to 8, not 9. So when you think through the combinations here, there's really nothing that works. There's nothing that works here. And when you have when you're trying to think of these combinations and you've come up with everything and there's nothing that works there, that means that this is not factorable. You just can't do it. Okay, so this would be not factorable. It's kind of similar to when we talk about just numbers and I say, all right, think about the number 19. I say, okay, how do we factor 19? Right? What are the ways I can break that up? You say, well, nothing divides into 19. Right? I can't factor that besides just 1 times 19 because it's a prime number. Kind of similar in this case as well. When I say factor this polynomial, you go through the combinations and there's really nothing that works there. So it's already factored. You can't actually factor this anymore. And so we just say it's not factorable, or we just leave it like that. All right, let's try H here. Same thing, okay? Nothing that I can pull out, so I'm going to do the 2 parentheses. And I'm going to go ahead and think about, again, snowflake. My a value is 1 and 1. A times c is negative 21, and the middle term is negative 4. So I think about what multiplies up to negative 21 and adds up to negative 4. Hopefully there's something there. I'm thinking 7 and 3, right? So if I have 7 and 3 multiplies up to 21, well, one of those is negative, and of course this one's going to be negative. Negative 7 times 3 is negative 21, and negative 7 plus 3 is negative 4. So this works. If both of those two things work, then the problem is factorable, and your answer, again, is right here, these two things. So we have an answer here of 1x minus 7, or just x minus 7, and 1x plus 3, and there's our answer.